Every day, more than 100,000 flights move through the skies above Earth. Some fly only a few hundred meters apart. Some cross oceans in complete darkness. Some disappear from radar for hours. And yet, mid-air collisions are incredibly rare. So how is this possible? How do thousands of aircraft, all moving at nearly the speed of sound, avoid crashing into each other every single day? The answer is hidden inside one of the most complex systems humanity has ever built. Most people imagine the sky as empty, but in reality, the air above us is filled with invisible highways. At any given moment, thousands of aircraft are climbing, descending, crossing continents, and approaching airports simultaneously. Over Europe alone, hundreds of planes can share the same airspace at the exact same time. And somehow, everything keeps moving with astonishing precision. Aircraft are not free to simply choose where they want to fly. Before departure, every flight receives a carefully planned route. Pilots follow designated airways, invisible corridors in the sky. Each route includes altitude, speed, waypoints, and timing. In many ways, modern aviation works more like a railway system than complete freedom. The difference is, the tracks are invisible. Behind every safe flight, there are people constantly monitoring the skies. Air traffic controllers track aircraft positions, altitudes, speeds, and directions in real time. Their job is simple in theory: keep aircraft separated. But in practice, it requires extraordinary concentration. One mistake could affect hundreds of lives within seconds. Aircraft may look close from the ground, but strict separation rules exist in every direction. Planes are separated vertically, horizontally, and by time. Even a difference of just 1,000 feet can safely separate two jets traveling at enormous speeds. Over oceans, where radar coverage is limited, the spacing becomes even larger. Radar coverage does not exist everywhere, especially over the Atlantic and Pacific Oceans. For decades, controllers could not continuously see aircraft crossing these regions. So aviation developed another solution: time-based separation. Aircraft entered specific tracks at exact scheduled moments. A system built on timing, discipline, and trust. Modern aircraft are equipped with collision avoidance systems called TCAS. These systems constantly monitor nearby aircraft independently from ground control. If two planes become dangerously close, the aircraft themselves issue emergency commands. One aircraft may be ordered to climb, the other to descend, and pilots must react immediately. Storms, turbulence, icing, and strong winds can suddenly force aircraft to change course. And when dozens of planes need rerouting at the same time, airspace becomes far more complicated. Controllers and pilots constantly adapt to changing conditions. The system works because flexibility is built into it. Today, satellites can track aircraft far beyond traditional radar coverage. Systems like ADS-B now provide near real-time position updates across huge parts of the planet. Artificial intelligence is also beginning to assist with traffic prediction and route optimization. The invisible system is becoming smarter and more automated than ever before. Most collisions do not happen in the middle of the ocean. They happen close to airports, during takeoff, landing, taxiing, and rapid altitude changes. This is where traffic density becomes extreme, and where precision matters most. From pilots to controllers to satellites to software to invisible procedures most passengers never notice, modern aviation depends on coordination. Millions of people safely cross the planet every single day because this hidden system continues to function almost perfectly. And most passengers will never realize just how much precision is required to keep two aircraft from meeting in the same piece of sky.